an 880 Newton person standing on a scale in an elevator. As the elevator begins to move, the scale reads 920 newtons. What was the acceleration of the elevator as it began to move? So we have a scale. We have a person standing on the scale in an elevator. Since we're given information about the person, that's who we want to look at in terms of looking at Newton's second law, F equals ma. We know the net force acting on the person causes the person to accelerate. The person will accelerate at the same rate the scale accelerates, which is going to be the same as the elevator car accelerates. You okay with that? It all accelerates at the same rate. So our person, we have a normal force. What's causing the normal force?
Scale.
Scale, standing on the scale. So the scale is what's pushing up, that's the surface. Scales read however hard you push on them. So the normal force is how hard the person pushes on the scale. The scale reads, therefore, how hard it pushes back on the person as well. Newton's third law. For every action, there's an equal and opposite reaction. However hard the scale is pushing on the person is pushing on the scale. The scale reads how hard the person is pushing on the scale. So the normal force is the force that the scale is reading. We also have a force of gravity acting on our person. The 880 newtons is the force of gravity. Newtons, remember, is a measurement of force, so it already is the force of gravity. The normal force, so if we look at the period of time when the elevator is accelerating, the normal force is the 920 newtons. So net force, we have 920 newtons upwards. We have 880 newtons downwards, so we have to put the negative sign on it. So the net force is 40 newtons. That has to equal the mass of our person times the acceleration of our person. Now mass, what units does mass have? Kilograms. We know force of gravity is mg. So the mass will be 880 newtons divided by 9.8 meters per second squared. So 40 divided by this stuff, acceleration ends up being 0.45 meters per second squared. That's the magnitude. We also want the direction. Well, the direction of the acceleration is always the same as the direction of the net force. The net force determines the acceleration. Whatever direction the net force points in, the acceleration points in. So the net force, this 40 newtons, we got a positive value, so it means it's upwards. So that means our acceleration is upwards. So up is fine, upwards, positive y, 90 degrees, whatever. Up and down, up is fine. Since I don't know of an elevator that doesn't go up or down. They're usually moving walkways or something. Willy Wonka, okay, good point.